week about the thyroid gland, inshallah. So in the thyroid, we will be talking about the non-neoplastic disorders and the neoplastic disorders. Now, regarding, first of all, we should talk about the non-neoplastic. But unfortunately, the neoplastic has been kept first, so I will take it because it is much easier than the non-neoplastic. So neoplastic disorders of the thyroid. What do you mean by neoplastic?
Tumor.
Which may be
Benign or malignant.
which may be benign, which may be malignant. In the thyroid, the most common presentation of a thyroid disorder is a person coming to you having a thyroid swelling, a single swelling, solitary swelling, which we call a solitary nodule. Okay, what is this solitary nodule? This solitary So whenever thyroid swelling comes to you, it is in the form of a single swelling, a solitary swelling. How you will say that this is a thyroid swelling? Any test you will do on the patient itself, because there is neck location. You can say it is some other swelling also, muscular swelling or lymph node. How you can see? Thyroid hormone. No, just by clinical temperature. Palpation, examination, but how you will confirm that? Examination is good, you have to examine the thyroid.
Maybe more excretions from the stations.
It is clinically what we do. If there is swelling here, if you suspect it is in the thyroid area, ask the patient to swallow.
Let's move.
No, it will move during the swallowing. If it moves, it is thyroid. If it doesn't move, it is something else. Maybe a lymph node, maybe a muscular swelling or some other swelling. So this is one. Thyroid swelling moves during the deglutition. We call it deglutition or swallowing. So solitary thyroid nodule, these are localized, well circumscribed, solitary thyroid lesions, which may be neoplastic or may be not neoplastic. Okay. But nodules are more likely to be neoplastic if they are solitary. It means if you find a nodule which is one, it is more likely to be neoplastic. If they occur in young patients, more likely to be neoplastic. If they occur in men, more likely to be neoplastic. If they occur after radiation, more likely to be neoplastic. And if they are cold, cold means they do not take up the radioactive iodine. When we do the X-rays or other imaging studies, we give radioactive iodine. If it is hot, it is making the thyroid hormone, it will take up. If it is active, if the gland is active, it will take up the radioactive iodine. Thyroid will take up iodine. So if you give radioactive iodine, it will take up the iodine. Okay? But in case of neoplasias, most of the times it will not take up. So we call it cold swelling. There? Hot swelling means it will take up the iodine which you give from outside. Cold swelling means it will not take up the iodine which you give from outside. And this is radioactive iodine. Yeah. So you can detect it by the X-rays. So nodules are more likely to be neoplastic if they are single, if they occur in young patients, and if the patient is male, and if it occurs after the radiation, and if the nodule is cold.
So this one should
Yeah. It means that in neoplasia most of the time what happens? It is not functioning normally.
Because normally you will
Yeah.
take the.
It will take because it is forming the thyroid gland. What happens if thyroid swelling comes to you? You want to see it on the X-ray. But on the X-ray it will not be much clear. You want to see whether it is a hot swelling or a cold swelling. Hot swelling means you give radioactive iodine from outside. It takes the iodine. And you can detect it on the X-ray. It will give a different color. Okay, opaque. But if there is cold swelling will not take up the iodine. Because it is not manufacturing the thyroid hormone. So it doesn't need the radioactive iodine. Because it has lost its function. So only difference between the hot and cold is hot will take up the iodine,
And it's no.
yeah, and cold will not take up the iodine. But all the neoplasias are not cold. Some of them may be hot also, but less. Number is less. But in general, thyroid swellings are more common in females. This you should remember. Thyroid swellings are more common in females. Second, mostly the thyroid swellings are benign. They are benign. And benign may be, adenomas, and even you can find some hyperplasia, cysts, thyroiditis, inflammation of the thyroid. And if you find a thyroid swelling in a male, as we said, it is likely to be neoplastic, but this is going to be a benign neoplasia. Okay? Benign tumor, likely to be benign. If there is history of radiation, more chances of malignancy, not the benign. More chances of malignancy. And most of the thyroid neoplasms also present as solitary lesions, single lesion. But out of all the nodules which you will see, only 1% will be neoplastic. Okay? There will be other diseases also, like cyst is there, colloid goiter is there, multinodular goiter. So only 1% will be neoplastic.
The solitary thyroid nodule, is it same neoplastic?
No, this is what we discussed now. Solitary thyroid nodule may be neoplastic or non-neoplastic. It can be both. But more chances of neoplasia when it occurs in the young patients, in men, post-radiation treatment. Okay. More likely to be neoplastic. Solitary is more likely, but it can be non-neoplastic also.
Doctor, first slide in men, second slide is in women, female.
Yeah, I know what you say. Neoplastic. Neoplastic can be benign or can be malignant. So, if a solitary nodule occurs in a man, it is likely to be neoplastic, but benign neoplastic. Okay? This is the difference. Now, these are the types of solitary thyroid nodules. It can be hyperplasia, hyperplastic nodules, like goiters, enlargement of the thyroid. It can be adenoma, which is a benign tumor. Adenoma forming glands. Adenoma. Carcinoma is the malignant counterpart. Then it can be cyst, like filled with colloid. It can be infections, like abscess. It can be a part of the multinodular goiter. Then it can be thyroiditis also. So all the things can be there. The nodule is there. You can have hyperplasia, you can have adenoma, you can have carcinoma, you can have inflammation, you can have cyst, you can have abscess. So all the things can be present. Then it is up to you how you will evaluate. How you will evaluate the patient. Now if we come specifically directly to the tumors are the thyroid gland. There are benign tumors and there are malignant tumors. What are the benign tumors? Adenoma is forming follicles or the gland-like structures. Okay? So adenoma, the most common adenoma is follicular adenoma. Here, because in the thyroid, what is the normal structure of the thyroid?
Follicule.
Huh? Follicles. Follicles filled with. Follicles are filled with. Colloid. Isn't it? There are follicles around it. These are filled with the colloid material. Okay. Then the follicles are surrounded by. So in between the follicles, what you find?
Interfollicular tissue.
It is a parafollicular cells. What is the name of those cells? Very good. So in the thyroid, the structure of the thyroid is there are follicles which are filled with colloid, varying size follicles filled with colloid, and in between the follicles you have the parafollicular C cells. Okay? This is the structure of the normal thyroid gland. Now you can have, if we go for the neoplasia, we have follicular adenoma, which can be cold or hot, depending upon whether it takes the iodine or doesn't take. Then the carcinomas. These are the malignant ones, malignant neoplasias. So we can have papillary carcinoma, which is the most common. Papillary carcinoma means it will have the formation of papillae. It will have the formation of papillae. What do you mean by papillae? What are papilla or what are papillae?
This can,
Slide. Huh?
this can behave.
There is specific definition. You have this marker. I hope these are not permanent. There is a problem with this. If you come back. I was avoiding that thing. Then again pull it back. So papillae are like this.
Slide. Finger-like.
Finger-like projections. Yes, isn't it? Finger-like projections covered by epithelium. So this is the epithelium. And you have in the center what you find. Here not colloid but papillae. The structure of the papillae is you will have a fibrovascular core, isn't it? You have the vessels and you have the fibrous tissue. Anywhere you find a papilla, the definition is one only. Finger-like projections, finger-like projection covered by epithelium having a fibrovascular core. This is the definition everywhere. Okay? So this is the papillae and you will find these structures.
What's happening inside? Inside.
So inside fibrovascular core, vessels and fibrous tissue. So this is the structure in the papillary carcinoma. You will find the papillae. But we will tell you sometimes you cannot find papillae also. But how you will diagnose them? That is a later discussion. More than 85% of the cases. So don't go by the previous year's lectures. If you want to study these lectures. The thing is, when we are making the lectures, we go for the latest things which they can get. Updated textbooks. Suppose somebody was using or I was using the 8th edition last year. Now we are using the 9th edition. So what the things which we find have changed, like the numbers. We have to change it. We can, because of many reasons. Previously they said that this carcinoma is less, the papillary. It is around 70 to 80%. No, it is more than 85%. Isn't it? Maybe the detection levels have increased. Maybe the other reasons are there. So we have to change the numbers according to the latest things we get. Whatever the latest things we are getting, we have to change. Sometimes even we have to change the pathogenesis. Isn't it? We have to. Concepts are changed, so we have to change. So papillary carcinoma more than 85%. This is the most common. Follicular carcinoma 5 to 15%. Medullary carcinoma 5%. Follicular will have the formation of follicles. Papillary will have the formation of papillary. Medullary is something else we will discuss. Anaplastic carcinoma less than 5%. The most dangerous is anaplastic carcinoma and the most decent is the papillary carcinoma. The most common and having excellent prognosis, the papillary carcinoma. And most dangerous and least common is the anaplastic out of these four. Then rarely you can find squamous cell carcinoma and you can find lymphoma in cases of Hashimoto thyroiditis. It's an inflammation, Hashimoto thyroiditis, autoimmune disease. In those cases you can find lymphoma also.
Why anaplastic?
Why?
Why anaplastic is the most dangerous?
Because it is anaplastic. Anaplasia. You know the word anaplasia, you remember? Anaplasia. It refers to the malignancy features. Huh? Like the carcinoma. These are all carcinomas. But anaplasia means it is having high grade nuclear features which point towards the high grade malignancy. Like high NC ratio, very high NC ratio. Huh? Pleomorphic cells. That is the severe pleomorphism. Mitosis is present. Huh? So like that. So that is why it is more dangerous. So these adenoma and carcinoma. Among the carcinoma, the most common papillary, least common anaplastic. But rarely you can find squamous cell carcinoma and lymphomas also. No thyroid adenomas. The most common benign neoplasm in the thyroid is an adenoma. Okay? And the most common out of the adenomas is the follicular adenoma. Because thyroid has the formation of follicles. So follicular adenoma is the most common. And most commonly it is solitary, one, well encapsulated because it is benign. Cut surface, grey white to red brown, may show fibrosis or hemorrhage. And what you will find? You will find uniform appearing follicles which contain the colite. And you can find a capsule and the normal gland will be compressed. I will show you the diagram. But there will be no nuclear atypia or mitosis. It means it is benign. No atypical features are there. But other types of these adenomas are papillary adenoma and Hurthal cell adenoma. Papillary will have the formation of papillae but without nuclear features. Without nuclear features of malignancy. And Hurthal cell is one cell which is a metaplastic cell. The same cells of the follicles will undergo, they will be enlarged, they will contain more granular eosinophilic cytoplasm. We call them Hurthal cells. I will show you the diagram in the lab. So when we have this metaplastic change in the follicular cells, we call them as Hurthal cells. When we have predominantly Hurthal cells only, we call it as Hurthal cell adenoma. Okay? So it is only the change, the metaplastic change in the normal follicular cells. It will lead to Hurthal cell formation. So three types of adenomas are there: follicular, papillary and Hurthal cell adenoma. And the most common is the follicular adenoma. Structure is more or less same as a normal gland. Uniform appearing follicles which contain the colite. So this is the diagram. This is a adenoma here. This whole is the adenoma. This is the normal gland. This part. This is the adenoma well encapsulated. Capsule is intact and this is the central portion. It may be grey, white or red brown. Here it is red brown. Maybe the colite is more because of that. And here, what do you think which is the adenoma, which is the normal gland?
The influences
The right is the adenoma.
The right is the capsule. The upper one is the left one is the
Yeah, upper one is the adenoma. Why? Because the adenoma will grow and it will compress the normals. Look, these are compressed. So this part, this is the capsule, this is the adenoma. This is not compressed. And it compresses the normal part here. It becomes compressed. So normal gland, but this, more or less they look to be same, isn't it? Only compression wise. Otherwise you cannot differentiate. So this is more or less uniform follicles. It will compress the normal gland.
no nuclear change.
Yeah, no nuclear change will be there. But for that you have to bring it closer, high power view. Now the thing is, most of the time if you find a follicular carcinoma also, it will also have the same structure like the follicular adenoma.
But glioma.
Sometimes it will not, most of the time it will not have the nuclear atypia which you are looking for. Yeah, even the carcinoma. Then how you will differentiate between an adenoma and a carcinoma? The only thing which will differentiate are two.
Capsule.
It will invade the capsule or it will invade inside the vessels.
There is a value.
Yeah, there is invasion. So if somebody is saying, because most of the follicular carcinomas are also well differentiated. So they resemble the adenoma, follicular adenoma. But how you will differentiate? You have to see the vascular invasion or the capsular invasion. I will show you the diagram. So this is very important. Both are composed of well differentiated follicles. So you cannot say, if you do not find the nuclear atypia, you cannot say this is carcinoma and this is adenoma. Because both are same. So only evidence is capsular and on vascular injury. So this is, look here,